Good morning. Welcome to Making Stuff with Chris Dayhut. As the title of this video implies, I'm taking a look at a more efficient way to make circuit boards. These are the circuit boards I needed to make. I needed 16 total, but the prototype one will suffice for the 16th unit. Now my normal process is to go through and I would, on my first operation, do the engraving as seen here. Drill my holes and then mill the outline to free the PCB from the larger material. Then I would paint the surface where the legends would be, or the top surface of the PCB, put it back in there using two holes to very carefully register it perfectly with the same location on the router. Then I would engrave the legends on it at that time. Overall, it's a pretty efficient process doing them one by one. I would do the engraving and hole drilling on the back side with milling the outside profile of it to free it up from the larger stock material. Then I would spray paint it, and while that's drying, I would move on to the next circuit board and get that one engraved. Usually by the time I get all of the first ops done and the painting done, then I can start putting these back on the router and doing the engraving. I use an alcohol-based paint and acrylic, and it dries pretty fast and it works pretty efficiently. But when you start getting up to this many of them, it gets to be old real quick. And that's where I thought about doing panelized circuit boards. And it turns out it is much more efficient, and I could get, I think, all 15 of these done in about 2 hours, maybe 2.5 hours. I was doing other things during the process, so I didn't keep accurate time. But I was able to get these banged out pretty quick, and I'd like to show you that process today. Using Sprint Layout version 6.0, which I've been using for many years now, I go through, design my first circuit board panel, and once I'm comfortable with it, then I'll group all those elements and then start copying and pasting them. You'll see that white, dark or thick white boundary line around the PCB. That is showing the tool, I'll call it an end mill, that's going to go around the outside of the PCB to cut it away from the larger panel, which is represented in that grid-like pattern, black and gray pattern behind the smaller PCBs. Once I get it laid out, I do my best to observe it and check it for problems, save it, and then from there I can have this software output isolation milling files, and this works out really good for my process. I'll select isolation milling. I want to just do the bottom right now. I will mill from the bottom. I don't want to do outline. I do want to include drilling, and that's shown here in the job list. I make sure my units are set correctly and I click create. Now I'll go through and do the top panel, or the top side of the PCB. Export, isolation milling, turn off bottom, turn off drilling, turn on top, make sure I'm doing single line engraving, and then turn on the outline milling. And that's done with that end mill type tool. And then I'll create that job list. Now this job list is not CNC code that I can put in my router. That requires this piece of software. I wrote this in Python a number of years back, and what it allows me to do is open that job list file, and then it'll show me, like in this case, we're looking at the copper side of the PCB, and this is the full panel. I'm going to check all my milling settings for drill depths, speeds, feeds, etc. And then when I'm happy with it, I'll click Process and Save. Now my software is going through and converting this all to G-code style programming that the CNC router uses. It also goes through and plots this while it's doing it so that I can verify I'm getting the exact same output as input based on the sprint layout data. All that looks really good. We will go through, open up another job list for the second operation, which is the engraved side of the panel. Takes a second to load that. Move it so I can see it. Everything looks correct. You'll see the gaps in the outline. I'll check my tooling, speed, and feed information. Click Process. And again, it's creating the G-code program. This saves a tremendous amount of time, and it gives me a way of verifying the program as I'm creating it for the CNC router. And because I wrote this processing program, it also outputs the code exactly how I want it to for the CNC machine. Now I should note it's not real-time engraving or plotting. It definitely isn't doing that. And that creates the entire program and gets it ready for me to load into the CNC machine. Now I'll start out by setting up the machine. I use double-sided tape to hold the PCB material onto a spoil board. The program is already loaded. We'll graph it out. Look at that. That's exactly what we were getting in the code that I created. All looks good there. Now I'll hit cycle start, and the machine goes about doing its job. This particular CNC machine, it's a DIY one. I built this a number of years back. It has automatic tool changing on it. So it'll go through, pick up a tool out of the rack, tighten it up in the collet, and that makes sure it's good and tight and very consistent. After it tightens it, it'll then go over, measure how long the tool is very accurately, and from there it'll come over after the spindle winds up. This program is probably running 18 to 20,000 RPM for the engraving tool. And then it goes about milling all the traces and pads, etc., so that they are isolated from the rest of the copper. It's just a V-shaped groove. After it does that, it'll go over, grab the next tool, load it in, and this one will be a small drill. I believe it's 33 thousandths, which would be about 0.75 millimeters. And it just goes through and very rapidly drills all the holes. Now we'll go through, change tools again. And all the while this is going on, except for blowing off chips and so forth, I can be off doing something else. Here we're going through doing the large 1/8 inch diameter drilling, and that's about 4 millimeters. This is what the panel looks like. You can see all 15 PCBs on there, all isolation milled, all holes drilled precisely and in very accurate locations. Now before I take this off, generally I do go through, sand it up a little bit with some very fine sandpaper to knock off any burrs, and I'll clean it up with isopropyl alcohol thoroughly, and then we'll paint the other side, the top surface, side opposite of what we see here. We'll paint that with an alcohol-based dark colored paint, and then that way when it's engraved, the G10 material, that fiberglass board, looks very white after it's milled, so using a dark paint helps the lettering stand out good. To get this whole panel back on the CNC router and perfectly registered to the same location where it was for the first operation, I used 2 dowel pins that are very tight fitting to align the 1/8 inch diameter holes on both the PCB and the spoil board underneath. Once that's all done, I'll go through, load up the program, and we'll take and graph that and make sure everything looks correct there. And as you can see, although a little bit blurry, it does look like what I want it to look like. Those red lines that you're seeing are the rapid moves between each of the cutting moves that are shown in yellow and green. All around, this looks like it should. I've got my gaps in between each of the little PCBs, so they shouldn't come flying off the table as each one is machined completely around. Cycle start, let her run again. She'll go through, pick up a tool, starts out with the engraving bit. This is what that process looks like. As you can imagine, it's very tiny. It requires very precise movements. Any deviation and near perfection, and you're not going to get proper engraving. This can even be difficult on some very large industrial machines. If you happen to notice why the router wobbles a little bit, it's on wheels. Now you're going to see the outside of the little PCBs be cut away. Normally I have a full-blown industrial dust collection system on here, but I can't film with it. So I use a shop vac while filming so that I can show you folks what that process looks like. It'll just go through, mill them all out. This is what the whole panel looks like now. None of them flew off, none of them broke. And everything is just where I want it and just the way I expected it to. Now I'll take each one of them, break them out of that rack, and I'll cut off the little nibs on the edges and sand those edges smooth so that they're not rough or sharp, especially on the copper side. But that's the completed circuit board. That is my method for doing panelized circuit boards. Very efficient. If you're not doing it, you might want to look into it the next time you've got multiple boards to do. Well, that'll wrap this one up. If you have other suggestions, or if you would like to see other parts of my process for making circuit boards in more detail, leave me a note in the comments below. Also, I'll have links to some of my other videos on making circuit boards. Thanks for watching. I look forward to seeing you in the next video.